Alright, so the last two problems involve triangles that are not necessarily right triangles. So SOHCAHTOA, everything we've done up to this point was just for right triangles, but as we know, not every triangle is a right triangle. There's other kinds of triangles out there. So what we want to do is that you notice the triangle's not drawn for us, there's no words, we just got to draw just a generic triangle. So I'm going to draw a triangle here, and I started to draw a right triangle. Let me just kind of draw a generic triangle that's not a right triangle. Alright, so as far as the labeling, you're like, well, okay, so what do I label all this stuff as? Well, so there's one thing we use, so take a look at this over here. So capital letters, so for capital letters represent angles. So where you see this capital A, capital B, capital C, that means angle A, angle B, angle C, right? That's what those angles mean. Lowercase represents sides. So you see little a, little b, little c. So, and they always match up. So like big A, so if I look across from big A, there's little a. Or if I look across from big B, there's little b. Right, so that's the way it works. And it doesn't matter where you put your A, B, and your C. So you notice they have their A at the top. Just to show you it doesn't make a difference, I'm going to do my A, B, and C like this. Now what that means is that if I'm saying this is angle A, then that means that's going to be little a. And then if this is big B, that means this is little b, and then that's little c. Right? Alright, so let's fill in what we know. So it says that angle A is 35 degrees, so that's 35 degrees. Angle B is 55 degrees. And then it says little a is equal to 8. And then it says find B. So B, that means that's what we're solving for, right? And then so with this one we know an angle and a side, and then we know an angle, but we don't know this other side. And so what we do is we pair up. Right? So if you take a look at this, we got a side, angle, side, angle, side, angle. And so what we're going to do is we're going to pair each one of them up. So what we have is that I pair up the one I know that's I would say is complete, meaning I know both the side and the angle. So that would be A. I know both A's side and angle. So I would have 8 over sine of 35 degrees. And then I pair up the side that I'm looking for. So I know angle B, I just don't know side B. So what we're going to do is that we'll set this up as, I'll just leave it as B, because that's what I'm looking for. And then I've got the angle sine of 55 degrees. So kind of like SOHCAHTOA, you just end up using 2 of the 3 sides. With this particular one, we end up using just 2 of the 3. So you notice that I don't know anything about angle C, and I don't know anything about side C. So that last part of the fraction I'm not going to end up using. I should mention one thing before we go much further with this, is that you might have noticed something, is that if you add 35 and 55 together, you get 90. So that means that this actually would be a right triangle. Let me draw it the same kind of direction. Because if this guy is 35 and this guy is 55, and we know they all add up to 180, that means that would have to be 90. So this one actually does end up being a right triangle. So my triangle that I sketched here is not really to scale, but it's a good lesson to see that what we're using here, the law of sines, it works for right triangles, but it also works for triangles that aren't right triangles as well. And then what we want to do is we just want to solve for B. Anytime we have a ratio, what we want to do is we're going to cross multiply. So I'm going to cross multiply this direction. If you think back to middle school, they probably told you about some sort of butterfly or something. So we'll do 8 times sine of 55 degrees. And then we'll cross multiply the other direction. So we'll do B times sine of 35 degrees. And then we just want to get b by himself. So we say, well, what's on the same side as b? Well, what's on the same side as b is the sine of 35. And it's being multiplied, so we know the opposite is division. And we'll do that to both sides. So I've got b is equal to 8 times sine of 55 degrees divided by sine of 35 degrees. And at this point we've done as much as we can by hand, so we'll go ahead and put it into the calculator. So we'll do 8 times sine of 55, and that's going to be divided by sine of 35. And so we get approximately 11.4. We don't have any units on this. I'll just say meters by default. We want to make sure that answer is reasonable. So if this side is 8, could this side be 11? Sure, that's a reasonable answer. So again, what we've used here, the law of sines, works for both works for right triangles, but it also works for triangles that are not right triangles. So it works for both kinds of triangles. It just happened to be that this one's a right triangle, but I'll tell you, the one that you're going to see on the test is actually not a right triangle. But I should mention too is that we could have used the law of sines on this one as well. Just personal preference. If it's a right triangle, I think SOHCAHTOA first. If it's not a right triangle, then law of sines. Alright, so go ahead and stop there and try number 10.